at the input side of most switched mode power supply, you will find this component. This yellow component here. In the other power supply, you can see it is a black component. This component is called the class X capacitor, and it is a safety capacitor, and it is used in conjunction with a fuse. You can see this fuse. There is also this fuse here. The class X capacitor is an AC capacitor. It operates on AC. You can see from this circuit at the input side, our live here is connected to one terminal of this class X capacitor. This is the life of the input connected to the one terminal of the class X capacitor, and then to this fuse, and then from this fuse it is connected to the bridge rectifier. This is the bridge rectifier chip, and then our neutral here, it is connected to the other terminal of the class X capacitor and to the bridge rectifier. This is how the circuit looks like. You can see our fuse here, and then our class X capacitor. The class X capacitor is connected between the live and the neutral at the input, you can see, and then our fuse here, and then our bridge rectifier. So the class X capacitor is used to filter electromagnetic interference due to unwanted high frequencies. That is noise. This noise is caused in the line by connection of other devices to the mains, like motors, which can generate high frequencies, and these high frequencies can go back to the line. These frequencies, when you are operating your switched mode power supply to power sensitive devices, if not protected, can go into the SMPS power supply, and you find your SMPS power supply is not operating at the required levels, or is not giving you the output you require. In this other SMPS power supply, you can see the fuse is here, the class X capacitor is here, and is connected with two inductors. There are two inductors in line with the bridge like this. So how does this class X capacitor protect our circuit from high frequencies? We know that the internal resistance of the capacitor is called the inductive reactance, and is given as Xc is equals to 1 over 2 pi Fc, where F is the frequency of the AC supply and C is the capacitance of this capacitor. So this class X capacitor is like an open circuit when our frequency is 50 Hz. If you evaluate this formula, you will find that the inductive reactance of the capacitor, which is the internal resistance of this capacitor, reduces as the frequency increases, is inversely proportional with the frequency, and with time, if these high electromagnetic frequencies introduced in the line by other components connected to the line, if they go too high, the internal resistance of this capacitor will tend to become zero. When it becomes zero, it acts as a short circuit and provides the easiest path for the current to flow back to the supply. Hence, acting as a short circuit, the high current will flow through the fuse and causing the fuse to blow, hence protecting the other components in the power supply. So that is how the class X capacitor is used to protect the sensitive components of the switched mode power supply.